Today's lesson is in chapter 4. It's about isosceles and equilateral triangles. 4-6, isosceles and equilateral triangles. And this first video is going to focus on isosceles triangles. So an isosceles triangle is a triangle with two sides that are two equal congruent sides. They have equal measure. And then the third side is kind of the odd man out. It's not equal to the other two. So in an isosceles triangle, that third side that's not equal to the other two, we call that the base. So that's this guy here. My dog drinking water in the background, super loud. This is our base. And then these two congruent sides, think of it like a party hat or an upside down ice cream cone, something like that. These two congruent sides, we call these the legs. Think about it. You have two congruent, for the most part congruent. Not everybody's legs are congruent, but two congruent legs. So the two congruent sides of an isosceles triangle are the legs. The third side is the base. And then these two angles that come off the base, these are called base angles, right? These two angles are our base angles. So kind of easy to remember, right? We've got our base, and the two angles touching the base are the base angles. And then that third angle up at the top, this guy here that's not like any of the other angles, is called our vertex. The vertex angle is always across from our base, right? So there actually is a relationship between one side of our triangle and the angle across from it, right? So if we think about it, this base here is the only side of all three that's not the same as the others, right? The vertex is the only angle that's not the same as the others. So there's a relationship there. Our legs are congruent, and the angles across from our legs are congruent as well. So there is a relationship. So in a specific triangle, if one of these base angles is, let's say, 30 degrees, and the side across from it is, let's say, a length of 5 feet, let's say. If the other angle is 30 degrees, the side across from it has to be 5 feet as well. It's kind of like a little ratio that's set up, right? So our two legs have congruent base angles across from them, and then our base has the vertex angle across from it. That's the biggest thing you need to understand about isosceles triangles, and all of our theorems and stuff we're going to go over come off of this. Okay, so I'm going to put that off to the side. And here, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Okay, so this is the isosceles triangle theorem. If two sides of our triangle are congruent, then the angles across from them are congruent. So if these two sides are equal, then the angles across from them are equal. And the two equal angles are our base angles, right? In this in the wording of this rule, first it talks about two sides. So first thing we know is that the sides are congruent. Then we can assume, or we can come up with the conclusion that the angles are congruent, right? That's our isosceles triangle theorem. The converse isosceles triangle theorem talks about the exact same thing, but instead of us knowing that the sides are congruent first, in this case, in the converse, we're going to know the angles are congruent first. So if two angles are congruent, then we know that the sides are congruent. So to know which rule we're talking about, if we're using a proof or answering a question, just look at the order of the wording. If we know the sides are congruent, and then we have to figure out about the angles, that's the isosceles triangle theorem. If they first tell us the angles are congruent, and then we have to figure out that the sides are congruent, that's the converse, right? Just flip-flops the order. So let's do a few math problems with that. All right, so example 1, find x, given that BC is congruent to BA. So here, BA is this side, BC is this side, and then the only x's are talking about the measure of these angles, right? And with the isosceles triangle theorem, let me zoom in a little bit. With the isosceles triangle theorem, we know sides across from angles. Angles across from congruent sides are also congruent. So this angle has to be the same size as this guy, which means to solve for x, I just have to set them equal to each other. So 4x plus 5 equals 5x minus 10. And then I can just use algebra to solve for x. Minus my smallest x. These go away. I'm left with 5 equals x minus 10. I'm going to add 10. So I got to do the same thing here. So I end up with 15 equals x. So when I write my final answer, you always want to write x first. There we go. Next one. Similar. These are all similar. They're the same types of problems. We're just getting examples in so you can use them when you do your assignment. Here we have two angles marked congruent. So we know the sides across from them are congruent as well. So this side has to be congruent to this side. Oops, that was not a straight line. So I know 3x minus 13 has to be equal to 2x. And then I can use algebra to solve, get rid of the smallest x. X minus 13 equals 0. And x is going to equal 13. So these are our two examples. So let's try a few on our own. I would recommend you guys pausing the video and trying these on your own. It doesn't hurt to just hit the pause button, solve this, and then hit play and watch me solve it and just check your answer. Okay, so for number 1, we have two sides marked congruent, this guy and this guy, which means this is our base. So these are our base angles, right? The angles across from the congruent sides are congruent. Okay, so I know that angle R has to be 2x, has to be the same as angle Q. And I know that all three of these angles add up to 180 degrees. So 40 plus 2x equals 180. And then I can just solve for x. X equals 35. Make sure you guys are showing all of your work whenever you're solving on your paper. Those of you that say, well, I did it in my head, or I did it on the back of my paper and then I threw it away, or I gotta see the work if you want the grade. You guys are doing a lot better with that now. Okay, here we have another isosceles triangle. We have two congruent angles. So these sides across from them have to be congruent. This guy congruent to this guy. So we set 2x plus 6 equal to 3x minus 6 and solve for x. Minus 2x, add 6. So x equals 12. And number 3, again, pause it and try it on your own. I know this angle down here, angle A, is the same as angle G. And we have 2x up here, and I know all three of these add up to 180. So I'm going to say 2x plus, and instead of writing this all out twice, I'm just going to multiply it by 2. And set it equal to 180. Okay. And then use all my distributive property and everything I know to get x alone. I'm going to go ahead and combine the x's and subtract 12 on both sides. Divide both sides by 14. And you should get x equals 12. Zoom it on out. Now we have a lovely proof, and this is the last part of this video, so hang with me. All right, it says, write a 2-column proof. Given that angles 1 and 2 are congruent, this guy and this guy, prove that AB is congruent to CB, that this guy is congruent to this guy, right? So basically, we're trying to prove that this is an isosceles triangle. Okay, so I have my statements, my reasons. Got to write down my given first. Oops, step 1, angle 1, congruent to angle 2, given. Okay, so based off of that, this angle is congruent to this angle. Angles 1 and 2 are congruent. What else do I know here? This guy's congruent to this guy. What else can I say are congruent now? What other two angles? How about 2 and 3? 2 and 3 are congruent, right? Because why? Because they're vertical angles. So that's the vertical angle theorem. So if angles 1 and 2 are congruent, I know angles 2 and 3 are congruent. I'm going to list that next. Angle 2 is congruent to angle 3. That's the vertical angle theorem. And I have it marked. So then what can I say? Well, obviously angles 1 and 3 have to be congruent, right? If 1 and 2 are congruent, 2 and 3 are congruent, then angles 1 and 3 have to be congruent. And the way I wrote it, this is actually the transitive property. Oops. Angle 1 is congruent to angle 3. Because angles 1 congruent to 2, and then that same 2 is congruent to 3. So the 2's are in the middle. And I can just cut out the middleman and say that 1 is congruent to 3. That's the transitive property. If I had flipped anything, if these 2's weren't back to back, then it wouldn't be the transitive, it would just be substitution, and that's fine. But in this case, how I wrote it, 1 equals 2, 2 equals 3, the 2's are in the middle, so I can get rid of them and say 1 equals 3. Then this is transitive. Saying the same thing as substitution, it just depends on the order, right? So now we've said angles 1 and 3 are congruent. So didn't we learn a rule about that today, right? If we have two angles that are congruent, the sides across from them are congruent, right? That's our Converse isosceles triangle theorem. If two angles are congruent, the sides across from them are congruent. Transitive, blah, 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 blah. Okay, so for the isosceles triangle theorem, then we can say that CB is equal to AB. Sorry, I'm like going back to proving triangles congruent. AB is congruent to CB. This guy is congruent to this guy because angles 1 and 3 are congruent, right? So AB is congruent to CB, and that's the converse isosceles triangle theorem, which is, again, up here, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. Our two angles here are this guy and this guy, so the sides across from them have to be congruent, and I had to prove that AB and BC were congruent. So that's what I did. Here's your proof. Hopefully that helps. Let me know if you have questions.